Hey there, amazing viewers. Welcome back to another exciting tutorial on our channel. We're diving into the world of Python programming once again. If you're a beginner looking to supercharge your coding skills, you're in the right place. In today's episode, we've got something special lined up for all you beginners out there who are eager to level up your Python skills. We're going to unravel the mysteries of Python list methods. Get ready to conquer lists like a pro. Smash that like button, hit subscribe, and let's dive headfirst into the wonderful realm of Python list methods. I'll see you in the tutorial. We're going to learn about a really useful tool in Python that helps us find the position of an item in a list. It's called the index method, and I'm going to walk you through it step by step using simple language and real-time examples. So grab your favorite code editor and let's dive in. We'll start by defining a list. For our first example, we'll start simple by creating a list of names. Let's start by creating a list of names, similar to how you jot down names in a notebook. Got it? Great! Now, we'll embark on our journey to find the precise position of a particular name in this list. Let's say we're on a quest to locate Charlie in our list. Buckle up, because here's how it's done, line by line. Here's how you do it using the index method. We set our target name to Charlie, the treasure we're seeking. Using the index method on our names list, passing in the target name. This method magically returns the position where our target name is located in the list. Python searches our names list for the position of Charlie. And finally, we use a print statement to display the result. In print statement, we're using something called an F string. Here, an F string is like a magic wand for formatting text. It lets us create a string where we can insert variables directly into the text. Think of it as a way to combine words and values seamlessly. So let's break down this line step by step. This part simply tells Python that we want to print something on the screen. Here, the F at the beginning indicates that we're starting an F string. It's like a signal to Python that we're about to do something cool. We begin our string with the text, the name. This is a fixed part of the message that we want to print. Inside the string, we use curly braces to tell Python, hey, I want to insert a variable here. And that variable is target name, which is the name we're searching for. 5. We continue with our fixed text by adding is in slot. Again, we use curly braces to insert another variable. This time, it's position, which is the result of the index method, the slot where our target name is located. We finish the string with the closing quotation mark and a closing parenthesis to complete the print function. When you run this line of code, Python works its magic. It takes the value of target name, which is Charlie in our case, and inserts it into the string where we used target name. Then, it adds the fixed text, is in slot. Next, it takes the value of position, which is 2, since Charlie is in the third slot of our list, and inserts it into the string where we used position. Finally, Python completes the string and prints the entire message. Let's see this in action. When we run our code, Python does all these steps behind the scenes and gives us a clear and informative message. The name Charlie is in slot 2. And there you have it. This line of code might look complex, but with the power of F strings, we're able to create dynamic and customized messages effortlessly. Now, let's explore a new scenario using the index method. What happens if the name we're searching for isn't in the list? Python might get upset, but we can handle that. Get ready as we tackle this challenge step by step. Imagine we're back to our list of names: Alice, Bob, Charlie, David, and Eve. But this time, we're on a quest to find someone who's not on the guest list. Mallory. Let's try looking for Mallory, a name not in our list. We begin by defining our target name. This time, it's Mallory. We've got our target set, and now we're ready to hunt for Mallory in our list. Before we unleash the index method, we need to be cautious. We're going to use an if statement to check if Mallory is in our list of names. Now, using the index method on our names list, passing in the target name, this method magically returns the position where our target name is located in the list. Here's what's happening. This line checks if our target name, Mallory, is present in the names list. If Mallory is indeed in the list, we execute the next indented block of code. Just like before, we use the index method to find the slot where Mallory is located. We print the success message indicating where Mallory is in the list. We handle the absence of Mallory with a message that lets us know she's not on the list. Let's see how this plays out in real time. If Mallory is present in the list, we'll get a message like, "The name Mallory is in slot X." But if she's not invited, we'll see, "The name Mallory is not in the list." Let's run our code and see the result. And there you have it, folks. Let's explore some examples where there are duplicates of a value in a list, and the index method returns the index of its first appearance. All right, my fellow coding explorers, it's time to unravel the mysteries of duplicates in a list using the trusty index method. Imagine we're delving into a treasure trove of numbers. Some are the same, and we're on a mission to find the very first appearance of a specific number. Grab your coding compass as we navigate through this step-by-step journey. Prepare for a mini-adventure as we embark on one example. Picture this. We have a list of numbers: 5, 10, 15, 10, 20, 25, 30, and 10. Our goal? To pinpoint the first appearance of a specific number, in this case, the number 10. Let's kick things off by defining our list of numbers and the target number we're hunting for. Number 10. Behold the mighty index method. This is where the magic happens. We're going to use it to find the position of the very first occurrence of our target number. With this line, we're saying, "Hey, Python, find the position of the first occurrence of target number, which is 10, in the numbers list." Time to bask in our success. We're going to print a message that reveals the treasure we've unearthed, the position of the first occurrence of the target number. With this line, we use an F string to weave together a message. We insert the value of target number and the value of position into the message, creating a customized and informative output. As we run this code, Python springs into action. In this example, we have a list of numbers, and the value 10 appears at positions 1, 3, and 7. However, the index method returns the position of the first occurrence, which is 1. It scans through the numbers list, detects the first appearance of our target number 10, and triumphantly announces its position. Keep in mind that the index method is your guide to the first appearance of a value. If you're interested in other occurrences, you'll need to explore additional techniques or methods. And there you have it, explorers of the coding realm. We've cracked the code on finding the initial appearance of a value amidst duplicates using the index method. We've covered the full journey of using the index method to find a name in a list. We've handled both success and absent scenarios like pros, but hold on to your coding hats because our journey is far from over. We're about to set sail into uncharted territories as we embark on a new topic, such as the append and insert methods. Get ready to witness your coding skills soar to new heights. Picture this: a blank canvas, our Python environment. It's as if we're entering a virtual supermarket, armed with an empty shopping cart. Behold the creation of our empty list, the foundation of our shopping adventure. The code is simple but profound. By crafting the variable shopping list, we've erected our empty shopping cart, a list that will soon hold our desired items. As we step into the supermarket aisles, it's time to fill our cart with goodies. Behold the append method, a magical tool that allows us to toss items into our cart. Watch closely as we use the append method to add items. Each line magically drops an item into our cart: apples, bananas, and bread. Our cart is filling up with culinary delights. Hold your breath as we unveil the treasures within our cart. We're about to print out the contents of our shopping list, revealing the bounty we've collected. Let's run our code and see the result. There you have it. Our cart is filled with culinary delights. Now brace yourselves as we venture into uncharted territory, the insert method. Imagine having the power to place an item precisely where you want it on your shopping list. The method insert grants us this ability. With a single line of code, we command the insert method to add chocolate at index 1, right after apples. Our list bends to our will, accommodating our desires. The moment of truth arrives as we once again cast our gaze upon the updated shopping list. Will chocolate have found its place between apples and bananas? Behold the transformation. Through the print function, we witness chocolate seamlessly integrated into our list, an eloquent demonstration of the power of the insert method. As we run this code, Python springs into action. There you have it. Folks, insert method added chocolate to our shopping list. Kudos, intrepid coders. You've harnessed the might of append and insert, unlocking the art of adding items to Python lists. The append method gracefully appends to the end, while insert empowers you to choose your item's destiny. If you have any questions or feedback, please shoot in the comment section below. Guess what? Our coding odyssey is far from over. Get ready to dive into another thrilling chapter as we set our sights on a new list method that's about to take your coding game to the next level. Prepare to be captivated as we unveil the power of the remove method. This gem will empower you to seamlessly prune items from your list, making your coding experience smoother than ever before. Let's begin. Picture this: a versatile container, a haven for your data. A list in Python is exactly that, a digital treasure chest capable of storing multiple values. Just imagine a shopping basket, a single entity that can hold a collection of items. Whether it's your favorite fruits or a list of temperatures, Python lists are here to serve. Our journey begins with the creation of a list. Picture yourself jotting down your preferred fruits. With a few keystrokes, we can craft our very own list of fruity delights. We've breathed life into our list named Fruits. It's akin to a canvas waiting to be adorned with the essence of our favorite fruits. Now imagine a scenario where you wish to part ways with a specific fruit. Enter the remove method, your trusted tool for list surgery. Let's witness its might. A swift command, and Python acts. The remove method springs to life, eradicating banana from our list. It's like handing a grocery list to Python and watching it remove the designated item. Hold your breath as we inspect our handiwork. A single line of code is all it takes to reveal the fruits of our labor. The print function is our magnifying glass, revealing the altered list. Now we run our code and see the result. There you go. Notice how banana has gracefully departed, leaving room for the other fruits to shine. A word of caution: tread carefully. If you attempt to remove a value that's nowhere to be found, Python will not be pleased. Brace yourself for an error message, like a caution sign on the coding highway. Marvel as we unravel another layer of remove magic. When a value appears more than once, the remove method is diligent, removing only the first occurrence. If you seek to part ways with all duplicates, you'll need to wield other tools like loops or alternative methods. Let's assume one real-time example. Imagine you're in charge of temperature data. Our list of temperatures holds hidden gems, but we seek to remove a specific value, like sculpting a masterpiece. Behold the remove method in action. Visualize a list, a treasure trove of temperatures that paint a vivid picture of weather patterns. Behold the list of temperatures, a tapestry of numbers that captures the essence of climate data. In this symphony of numbers, we've orchestrated a list named temperatures. It boasts a collection of temperature values, each a unique note in our climatic composition. Now, imagine you have a specific temperature in your sights, one you wish to bid farewell. In our scenario, we've chosen the value 25 as our temperature to remove. The variable temperature to remove holds our chosen value, 25. It's like selecting a key to unlock the transformation we seek. The time has come to wield the remove method, our trusted tool for list surgery. Watch as we set it in motion. The stage is set, and the curtain rises. The remove method takes center stage, targeting the value designated by temperature underscore to underscore remove. With precision, it hunts down and eliminates the first occurrence of the specified temperature. Hold your breath as we unveil the transformation. A simple command exposes the metamorphosis of our temperature list. The list of temperatures appears before us, altered by the remove method. Notice how the first instance of 25 has vanished, leaving room for the others to shine. And there you have it, a mesmerizing transformation brought to life by the remove method. In a symphony of coding, you've witnessed the power to shape and sculpt lists with precision. Remember, the remove method is your conductor's baton, but ensure the value to be removed resides within the list's harmony. And that's it for now, folks. In this video, we've learned some cool and important stuff about list methods. But guess what? There's even more exciting stuff about list methods waiting for us in the next video. If you liked what you saw, give us a thumbs up. Remember to subscribe to our channel for more awesome Python tutorials, and make sure to hit the notification bell so you don't miss any of our cool episodes. Thanks for joining me today, and I'll see you in the next tutorial. Happy coding!